we shall consider another new topic, and the topic is waves. Under this topic, the candidates should be able to interpret wave motion. They should be able to identify vibrating system as source of waves. They should be able to use waves as a mode of energy transfer. At the same time, they should be able to distinguish between particle motion and wave motion. They should be able to relate frequency and wavelength to wave velocity. They should be able to determine phase difference, wave number, and then wave vector. They should be able to use the progressive wave motion, wave equation rather, to compute basic wave parameters. They should be able to differentiate between mechanical and electromagnetic wave, differentiate between longitudinal and transverse wave, distinguish between stationary and progressive waves. Then finally, the student should be able to solve numerical problems on waves. We are going to summarize this topic with these little notes. What is a wave? A wave is a disturbance which travels from its source to another point and carry energy along with it. That's a wave. We have two classes of waves: mechanical wave and electromagnetic wave. What is a mechanical wave? A mechanical wave is a wave that does not require a material medium for its propagation. It doesn't require a material medium for its propagation. And what are the examples of this kind of wave? We have sound wave, we have water wave, then wave of rope or spring. All these are examples of mechanical wave. For electromagnetic wave, it does not require a material medium for its propagation. But for mechanical wave, it requires material medium for its propagation. And that is what sound wave, water wave, wave on a rope, or spring. But for electromagnetic wave, it does not require a material medium for its propagation or to be transmitted. Example of this wave, we have light wave, infrared, light wave, we have gamma ray, you can also have X-ray, okay? You can have radio wave. These are examples of electromagnetic wave. The following question that relates with this topic, wave. So let's consider the following question, and as we continue, we will keep on emphasizing more about those things we need concerning this topic, wave. Question number 1 says, what is the period of the wave motion of frequency 50 Hz? The period T is what we are looking for. And what is the period? Period is the total time taken to complete one oscillation. Period T is the total time taken to complete one oscillation or one vibration. Okay? So what is the period of the wave of motion of frequency? So we are given the value of frequency F, which is 50 Hz. And we have one formula that connects both period of oscillation and frequency together. Period T is equal to 1 over F. Or you can also have frequency to be equal to 1 over T. This is the formula that connects both period and frequency together. So in this case, we are going to make use of this, which is equal to 1 divided by 50. 1 divided by 50, which is 0.02 seconds. The unit for period, once we define period as total time taken. Then, once it is defined in terms of time, the unit is seconds. So 0.02 seconds. And that is the solution to that question. Question number 2. A radio station transmitting at a frequency of 250 kilohertz emits wave of wavelengths. Find the velocity of the radio wave. We are looking for velocity. They are talking about wavelengths. How do we define a wavelength? Wavelength is the distance between two successive crests, or 12. Let us assume we have a wave. This is a wave. Okay? This is a crest. This is a 12. This is another crest. So the distance between two successive crests or two successive 12 is our wavelength. The distance between two successive crests or 12 is, so that's wavelength. The velocity, we also have the how wave is being propagated or transmitted with a particular what? Velocity. That's okay. So from here now, we can consider both frequency, wavelength, velocity are connected, they are related with this formula. Velocity is equal to frequency and this. We are looking for velocity. We are given this, we are given this. So which is equal to frequency. Please take note of this. This is kilohertz. The normal unit of frequency is hertz. 250 times 10 raised to power 3. Where are we having 10 raised to power 3? Kilo. This is now in hertz. It's no more in kilohertz. Then times wavelength 2 kilometer. Kilometer times 1000, which is equal to 250 times 2, 10 raised to power 6. And 250 times 2, 250 times 2, that should be 500 times 10 raised to power 6. 1, 2. 5 times 10 raised to power 2 times 10 raised to power 6, which is equal to 5 times 10 raised to power 8 meter per seconds. And that's the unit of velocity. Meter per seconds. And that's the velocity at which the radio wave will be transmitted. Question number 3 says, what is the frequency of the radio wave of wavelength? Look at the wavelength. The wavelength is 150 meter. If the velocity is 3 times 10 raised to power 8 meter per seconds, we are still coming from the same relation, but in this case we are looking for half. V lambda. This is what we are looking for. Make it a subject of the formula, which is equal to 3 times 10 raised to power 8 divided by 150, which is equal to 3 times 10 raised to power 8, 1.5 times 10 raised to power 2, which is 3 divided by 1.5 times 10 raised to power 8 minus 2. When this one moves up, which is equal to times 10 raised to power 6. And what we are having here, let's see what will be the value. 3 divided by 1.5 will give us 2. 2 times 10 raised to power 6 hertz. Hertz. And that's the answer for that question. The diagram above represents parts of a wave motion in air. If the wave travels with a speed of 300 meters per second, calculate the frequency of the wave. if we look at this wave, the diagram rather, this is one cycle, and we say the distance between one successive crest and another one is the wavelength. This is one wavelength. Start again. This is another wavelength. So this is one cycle, one wavelength, one wavelength. Then the remaining one doesn't give a full cycle. It's a half cycle. This is half wavelength. So we are going to add one wavelength plus one wavelength plus half wavelength. Then everything is equal to, because the total length of this whole wave is 1.3. It's equal to 1.3. 1 plus 1, that's 2.5. 2.5 wavelengths is equal to 1.3. And this is 2 times 2, 4. Plus 1. This is 5 over 2 wavelengths is 1.3. This is 5 over 2 is 1.3 over 1. If we continue, we are going to have 5 wavelengths to be equal to 2 times 1.3. So that wavelength will be equal to 2 times 1.3 divided by what? 5. So let's look at what will be the value of that. 2 times 1.3, okay, divided by 5, that is 0.52 meter, and that is the value of wavelength. The question now says, we have